Hi, my name is Angela, and this is my project on the endangerment of the red pandas. For some background information, in the recent years, humans have been making large impacts on the environment. Habitat loss nowadays is commonly attributed to human intervention. This includes things like clearing of forests to plant crops, poaching of animals for their furs, and other activities such as mining, which directly destroys the natural landscape. Activities like these affect many species, including monkeys, otters, dolphins, etc. While this affects a lot of different animals, I specifically chose red pandas because in the more recent years, red pandas have seen a huge decline in their estimated population. They live mostly in Myanmar, Nepal, and China, where they are being poached for their furs. In addition to this, deforestation especially hurts their habitats. This is the data I'll be using, which I got from redpandarescue.org. These are estimates of the population in the years from 2001 to 2017, which is 17 years. In the bar chart below, the x-axis is the years from 2001 to 2017 with increments of 1 year, and the y-axis is the population of the red pandas in increments of 2000. On the right is the exact same data that is being shown in the bar chart, but typed out. The first procedure I will be performing is the hypothesis test for slope. This is to answer the question, is there convincing evidence of a useful negative linear relationship between red panda population and years since 2001? The parameter is beta. Let beta equal the true average change in red panda population per 1 year increase from 2001. The null hypothesis is that beta equals to 0, and the alternate hypothesis is that beta is less than 0. This is not a two-tailed test because I want to see if the population of red pandas is decreasing. The significance level for this test is 0.05. To proceed with the test, we need to assume that the data is a representative sample and that each year is independent from one another. We also need the scatter plot to show an approximately linear pattern, and from the image on the bottom right, which is the scatter plot, we can see that there is indeed an approximately linear pattern. Finally, the variability in red panda population does not appear to be changing with the years. Using the formula T equals to B over S sub B, with B equals to negative 355.29411 and S sub B equals to 22.2780, that gives us the T critical number of negative 15.9482. The corresponding p-value is 4.073 times 10 to the negative 11, which is approximately 0. So to conclude, since the p-value is equal to 0, which is less than alpha equals to 0.05, we reject the null. There is convincing evidence to suggest that there is a useful negative linear relationship between years since 2001 and red panda population. Next, I will create a simple linear regression model. This is to answer the question, what is the correlation and relationship between years since 2001 and the red panda populations? So we need to check that the scatter plot shows an approximately linear pattern, and from the image on the top, we can see that there is an approximately linear pattern. We also see that the variability in the y values appears to be similar across the range of x values. We need to assume that each year is independent from another. And finally, we can see that this is approximately normal due to the residual plot not having any kind of pattern or curve. The linear regression model that I got was y hat equals to 725,715.294 minus 355.2941x. This is where y hat is the predicted population of red pandas based on the linear regression line, and x represents the year. The slope value that I obtained is negative 355.2941. To interpret this value, we can say that with each 1-year increase from 2001, there is a predicted decrease of 355.2941 red pandas. The R value is negative 0.9718. This tells us that there is a strong negative approximate linear relationship between years since 2001 and the population of red pandas. There is one unusually low outlier in the year 2017, which has an estimated red panda population of around 7,800. The R-squared value is 0.9443. This means that approximately 94.443% of the observed variability in the red panda population can be explained by the linear relationship with years since 2001. To reflect on this whole project, what went well was that it was relatively easy to find reliable data on the red panda populations. Some ideas for further studies is that I can try to analyze other animals that are also endangered, such as the black rhinos, gorillas, turtles, etc. And to summarize our procedures, from the slope of the linear regression model, we obtained negative 355.2941. This is quite an alarming number because this number tells us the predicted panda losses with each year. Next, our hypothesis test for slope revealed that there is a useful negative linear relationship between the panda population and years. So in other words, this tells us that the pandas are dying out. Taking all of this into consideration, it's clear that humans need to care more about the species that are placed in harm's way due to excessive human intervention and degradation of habitats. At the end of the day, it is important to remember that the Earth is also their home, so we should take more measures to protect our animals. These are my works cited. Thank you for watching.